Alright, I have start recording and today kita nak belajar the trends in periodic table. Okay, kalau boleh, kalau korang ada periodic table yang saya bagi tu, print out and laminate, that is the best lah. So, I'm gonna go quite fast sebab banyaklah juga kita nak belajar hari ni. So, don't worry, kita akan explain one by one. So, kita akan belajar pasal periodicity. Periodicity ni is just a fancy name untuk kita cakap kita nak explain the trends lah. So, kita most of the time kita akan tengok the across the period and across the first row of transition elements. Kalau you guys remember, the transition elements is yang dekat sini tu, dekat the D block. This is the transition element, or kita also know as D block. And another one is downer group. So for chapter 3, soalan ni almost untuk semua soalan is the same. Dia akan tanya across the period ataupun downer group, ataupun across the first row of transition elements ni maybe keluar, maybe not. That's it lah. So kita akan discuss the trend lah. Kita tengok apa perbezaan in the elements across the period and down a group. So first and foremost, kita tengok the variation in atomic radii. So what is atomic radii? Radii is a singular for radius. Okay, radius belajar matematik kan? So it is daripada center sampai dia punya circumference of the atom lah. So in this, kita imagine that every single atoms are round in shape. Okay, so kita bayangkan it is round in shape. Okay, nanti masuk cepat sikit Okay, so but how we describe the radius in atoms is a bit different. Okay, the size of the radius susah sikit sebab if you remember, you have a nucleus here and we have a cloud of electron. Okay, kita ada bentuk macam ni, ada yang bulat kan, macam s orbital bulat, ataupun ada bentuk cloverfield atas ke bawah semua tu. So it's actually the circumference of the atom susah sikit kita nak define. So kalau you guys tengok, there's no visible line where from the nucleus and at the very line where electron dah tak ada. Sebab dibayangkan macam dia adalah asap of electron, a cloud of electron where you don't really see the edge. So how do we figure out the radius? So it's taken as the half of the distance between the two nuclei of identical atoms. So caranya kita ambil two atoms. So contohnya chlorine ni suka bind dengan their own chlorine untuk produce chlorine gas. So kita biarkan chlorine duduk sama-sama dengan chlorine jadi chlorine gas, and then kita tengok the distance between two nuclei. So kita tengok distance between dia punya two nuclei, and obviously kita bahagi 2. And this is the unit of distance. It is Armstrong. Okay. Sometimes dia minta, sometimes dia tak minta. Ada dalam you guys punya tutorial book lah, dia punya unit conversion. You guys nak bagi dia dalam bentuk meter pun boleh. Okay, so this is the general idea of the atomic radii. If you see, kalau you nampak, we have a visible trend going down. Oh, sengit lah pula. We have a visible trend of going down a group and going across the period. Okay, kalau you guys tengok, going down and also across the period. Kalau if you notice that going down a group, dia punya atomic radii makin besar, while going across atomic radii dia mengecil. Okay, so kita akan discuss why is that so. So selalunya kita akan describe it from here lah. So kita akan start starting point mana-mana. Usually kita akan describe it from left to right and also from up to down lah. Okay, from left to right, the radius of the element decrease. Okay, kenapa? Okay, across the period, the radius decrease. Maksudnya across the period, kalau you guys tengok tu, dia makin kecil, makin kecil, makin kecil, makin kecil, makin kecil. Okay, what do I say by across the period? Kalau you guys tengok you punya periodic table ataupun dekat belakang saya ni, across the period, elemen yang hujung-hujung tu makin kecil kan? Mana saya punya periodic table? Sekejap ya. Alamak, periodic table saya pun tak ada. So, tak apalah. Let's see. Okay, let's see here. Dekat table and next time masuk cepat sikit jangan masuk lambat. Window attack. Okay, you guys boleh tengok the interactive periodic table yang saya bagi tu. So if you see that across the period, dia punya size makin berkurang. If I'm not mistaken, ia ada radii. So maybe not here. Tak apalah. I'm sure ada, tapi you guys tengok. Actually, going across the period, so this one dia ubahkan helium. The helium should be here. Okay, if you see. Across the period, dari kiri ke kanan, dia punya sizes makin mengecil, mengecil, mengecil and mengecil. Okay, why is that? Kenapa makin mengecil? So, the reason is we have something called effective nuclear charge. So, here. So, what is effective nuclear charge? Okay, across the period, the proton number increase and the number... ni salah ni. Wait Okay. Okay, across the period, the electron number increase. Okay, salah Okay, across the period, kita susun ikut electron number kan? And electrons is equivalent to proton number, remember? Sebab electron is negative, proton is positive. So, the number is always the same lah. Kecuali it is ions. So, across the period, kita susun ikut increasing proton number ataupun electron number. So, dia cakap nuclear charge ni increase. Apa tu nuclear charge? Okay, nuclear charge. Okay, nuclear charge ataupun kita denote as Z effective. So, effective nuclear charge is the attraction between the nucleus and the valence electrons. So, Z effective is the attractive force between the outermost electron dengan dia punya nucleus. Okay. So, kalau lagi tinggi Z effective lagi tinggi, maksudnya tarikan between these two lagi kuat lah. Okay. So, let's see why it is, how we define Z effective. Before kita tengok across the period, kita tengok dulu. Okay, Z effective. How do we define Z effective? Z effective is a purely number yang kita made up. Okay, diorang not actually have the Z effective yang amount yang kita bagilah. Okay, cara nak kira Z effective is Z is the proton number. Okay, and S is the effective nuclear charge constant. Effective effective nuclear charge constant. Okay, apa benda tu effective nuclear charge constant tu? Doesn't matter. It is very simple. It is just you punya proton number tolak dengan number of inner electrons. Okay, so how do we actually find that? So the first thing is, okay, you buat dia punya electronic configuration, which is the SPDF notation. So contohlah magnesium ada 12, so kita buat 1s2, 2s2, 2p6 and 3s2. Okay, what is inner electrons? Okay, inner electrons is dia punya electrons yang di dalam orbital paling dalam lah, basically. Maksudnya any electrons yang bukan valence electron. Okay, number of inner electrons ni is electrons yang bukan valence electron. Okay, maksudnya any electron yang bukan valence electron, that is inner electrons. Okay, so what is the effective nuclear charge of magnesium? Okay, magnesium dia punya proton number 12 lah kan, sama dengan dia punya elektron. So 12 tolak dengan the number of inner electrons. Okay, so 10. So dia punya charge is plus 2. This one you have to do plus 2 lah. Okay, plus 2 is just showing that it is force yang between the furthest electron and the nucleus. So why do we actually calculate this? Okay, bayangkan dalam nucleus, dalam you punya nucleus you ada banyak proton kan, proton which is I put proton plus dia punya charge. So we are actually looking dia punya attractive force dengan the furthest electron, which is the valence electron. So this tarikan is also dihalang oleh elektron-elektron yang in between lah, kan? So elektron yang dekat sini, dekat sini, dekat sini. This electron also dah guna sikit this attractive force. So that's why kita kira berapa banyak proton dekat dalam, berapa banyak proton yang ada dalam ni, kita tolak dengan the amount of electron yang in between the furthest electron. Okay, between the electron in between the valence electron. That's why kita dapatkan Z effective. And why we need to know Z effective is because valence electron, okay, valence electron defines the atomic radii. Okay, kenapa dia define the atomic radii? Sebab it is the furthest away. Kita consider it is lah yang kalau di orbit, kita consider dia lah yang the edge of the atoms. Okay, so let's see for aluminium. Aluminium kita susun all the 13, and now mana pula dia punya inner electron. So dia adalah Z effective dia adalah 13. Dia punya proton number is 13 tolak dengan inner electron which is 10. Sebab this is valence electron dia kan. So, tolak dengan valence electron. Okay, same for silicon and phosphorus. Okay, so it is basically proton number tolak number yang bukan valence electron. Okay, everything good so far? Good ke? Okay ke? Kurang okay ke?
Okay, sir.
Okay, good. So first row transition elements. So which one is first row? Which one is transition element do we even start with? Transition element is the element yang dekat D blocks, di mana kita isi lastly is D orbital. Usually kita isi yang macam kebanyakan yang kita tengok itu 4s and then kita isi dekat 3D. Okay. Transition elements, there's a reason they call it transition element. It is a very special element. Kalau you guys belajar chemistry pun nanti, you guys akan belajar this as a subject as itself. So, the first thing yang kita nak tengok is across the first row of transition element. Kita nak tengok the elements yang atas ni lah. Because it will be the same kalau you guys tengok yang bawah, the second row and the third row. Okay. So the first row of transition elements, kalau if you see, dia punya atomic radii daripada silicon, titanium, vanadium, chromium, dia makin kecil dia punya size. And then dekat manganese, iron, copper, nickel, cobalt, nickel, copper dengan zinc, dia jadi sama je, tak banyak beza. So in this, we actually are trying to justify kenapa the sizes tak banyak berbeza. When kita cakap awal-awal tadi, across the period, dia punya size should menurun, kan? Okay. So, kenapa dia constant? Okay. Banyak-banyak ayat ni, it just trying to say that when kita isi the electron on transition elements, kita isi ke 4s, okay, habis dah isi 4s, kita keep isi dekat 3D, 1 and then kita buat 3D 2 and then 3 and then 4. Okay, remember saya cakap hari tu untuk D blocks, this is the valence electron. Okay, but when we are looking at the atomic radii, okay, when we are looking at the atomic radii, dia punya this D orbital is considered as inner electrons, okay, so dia considered as the inner electrons. So apa yang dia cakap, even though the proton number increase, okay, but electrons are added to inner orbital. Okay, electrons are added to inner orbitals. So, even though the proton number increase, electron are added in the inner orbital. So, when proton number increase and then dia punya S pun akan increase. So, actually dia punya Z effective stay the same, remain constant lah, dia tak gerak sangat. Okay, one other thing you guys need to take account is screening effect. So apa tu screening effect? Screening effect is when you ada a lot of inner electrons. So macam saya cakap tadi, the electrons are keep added at inner orbitals. Alright. So ini macam dulu you guys buat masa high school dulu kan. Okay. So let's look at this. The screening effect is when the nuclear charge, which is the proton punya tarikan kepada elektron, is screened, dishielded, okay, dilindungi oleh elektron-elektron ni daripada kenapa tak tekan ni? Daripada boleh dirasai oleh elektron paling luar. So the valence electron ni tak dapat pun rasa kasih sayang proton ni, sebab the elektron yang tengah-tengah ni lindung. Okay, the elektron tengah dalam ni semua dia conquer semua kasih sayang proton tu. So proton ni tak dapatlah nak rasa elektron yang kat luar. So that's why it is cancel out by screening effect. Okay, so that's why kalau you guys tengok the graph tadi, the atomic radii tak change much. Okay, So, if you see, kalau you guys noted, there's a 2 mistake dekat sini. Can anyone point me out? Ni kita belajar chapter 2. Ada 2 mistake. Ada anyone perasan any mistake dekat sini?
CR and CU.
Yes. CR and CU. Okay. If you remember, it is the anomalous case yang kita bincang dulu. Chromium and copper. When kita isi, okay, ini lepas diorang isi and diorang susun balik sebab usually you guys akan isi 4S dulu and then baru 3D lah kan. Okay, contoh this one you guys akan isi. So, untuk tahu the valence electron, kita usually akan susun balik dekat luar. Jadi 4S dekat luar. So that is easy, you guys nak tengok dia punya principal quantum number. Okay, untuk anomalous cases, okay, sekejap I got a phone call. Okay, untuk the anomalous cases, untuk chromium and copper, we actually susun it is as 4s1 and 3d5, while copper is 3d10 and 4s1. It is the extra stability. Kenapa? It is the extra stability the T of half-fill and fully filled. Okay, outside of chromium and copper, kalau you guys tengok across the period, so this is the susun across the period, electron yang bila kita isi, we keep adding to the d orbitals. Kita keep adding to the d orbitals. Okay, so that means when kita keep adding to d orbitals, the electrons are added into the inner electron. So this is the inner electrons, and this is the valence electron lah dekat luar ni. So this is the valence electron. Ini semua inner electrons. Okay, so when it is added, kalau you guys remember, Z effective is equivalent to proton number minus S, which is the proton number. Okay, proton number Z kan, ataupun electron number. So proton number dia bertambah. Okay, contoh daripada 21 ke 22 ke 23. Okay, tapi the inner electron also bertambah together as the transition element. So the Z effective untuk transition element remains constant. Z effective remains constant. Okay, Okay, the only difference is untuk chromium dengan copper saja. So this is, so untuk chromium here is actually 23, and this one, yeah, so it is plus 1, and then this one also plus 1. So kalau you guys tengok, the Z effective is plus 2, beza sikit plus 1, and then most of it are plus 2. So if the Z effective tak berubah, it means that dia punya atomic radii also remain the same lah. It's around the same. So we consider around 160 picometer and 130, tak banyak sangat beza lah. Okay. So points to remember. Electrons are added in the same shell. So kita added into the 3D subshell. And then the number of atomos 4s remains the same lah. And lastly, this is the elaboration on why the Z effective and the atomic radii stay the same. So the effect of nuclear charge, proton ni nak tarik elektron yang dekat luar, is cancelled out by screening effect. So elektron yang dalam-dalam ni dia shieldkan elektron luar ni daripada rasa tarikan proton dekat dalam. So actually lagi banyak proton number, we keep adding elektron dekat tengah ni. Kita keep elektron dekat dalam. So tak ada beza pun. Even though proton makin bertambah, the kuasa tarikan lagi kuat, tapi kita keep adding the shield. So it is the same lah. Okay, now let's see down the group. Okay, menurun ke bawah. Okay, kalau down the group, you guys tengok, it is anything yang the atomic radii. Okay, down the group, tak kisahlah group mana. Kita tengok, what is the trend? Kalau you guys tengok, the trend actually going down a group, dia punya sizes bertambah. Sizes dia makin besar. Why it is the sizes makin besar? Tak kisah any group makin bawah makin besar. Okay, down a group, okay, kenapa size dia makin besar? Okay, if you tengok, how do we put one element dekat atas, satu lagi elemen dekat bawah? Kenapa hidrogen duduk atas lithium? Sebab when kita susun the electronic configuration, kita susun the period, okay, melintang ni, level ni, mengikut dia orang punya highest principal quantum number. So what is principal quantum number? And okay, lagi tinggi and lagi banyak energi yang elektron tu ada untuk duduk jauh daripada proton dengan elektron. Okay, so going down the group, okay, we are actually have n equal to 1, n equal to 2, n equal to 3, 4, 5, 6, so on and so forth. So that's why it makes sense that going down the group, the size increase. Okay, down the group, dia punya size increase. Okay, size dia increase sebab we have more and more shells. So bayangkan this one ada satu je, and this one ada 1s and ada 2s, this one ada sampai 3s, this one ada sampai 4s, and this one ada sampai 5. So lagi besar and samalah sampai ada 6. You guys boleh bayang lah kan. Okay, so descending a group atomic radius increase, so the number of electron shell increase, so it is further away between the valence electron and the nucleus. Okay, this chapter just a lot of reading. You guys boleh baca my slide tu lah yang I dah give tu. Okay, so macam mana nak ingat? So going down the group, okay, the principal quantum number increase, which is the nilai n, and then the shielding effect also increase. So lagi banyak shell, lagi banyaklah elektron yang dekat dalam tu kan. So the force of attraction between the nucleus and the outermost electron getting weaker. So the size jadi increase lah, sebab proton tu dah tak boleh dah nak tarik elektron yang dekat luar tu. Okay, so going down the group, the conclusion, going down the group, size increase. Okay, tapi going across the group, size dia makin mengecil. Kenapa dia makin kecil? Sebab Z efektif dia meningkat. The only exception of Z efektif tak meningkat is dekat transition elements, sebab Z efektif dia constant. Sebab if you remember, we keep adding dekat d orbital. Elektron semua masuk dalam d orbitals. Okay, simple enough. So this question you guys boleh try sendiri. It just want you guys to describe going down the group, going across the group, and also the transition element. You have only ada 3 type of question: across period, down a group, or the transition element. Tu je. So let's go untuk this. So this kita nak describe on other species pula. What is isoelectronic species? Okay, iso maksudnya same. Okay, iso maksudnya sama. And electronic maksudnya anything involving dengan electrons lah. Okay, isoelectronic species maksudnya is any atoms or ions or anything yang has the same electronic configuration. Okay, same electronic configuration. Macam mana diorang ada same electronic configuration? Okay, so let's see this. Fluorine. Okay, fluorine ada 9 electrons. Alright, so it has 9 electron, and bila kita susun the electronic configuration, it is like this. Okay, sodium ada 11, kita susun dapat macam ni. And oxygen kita susun ada 8 macam ni. And aluminium macam ni. Okay, tapi how it is the same is when kalau fluorine minus. Okay, fluorine minus maksudnya dia ambil satu elektron kan. Dia ambil satu elektron, dia tambah satu elektron sini, dia dapat sini. Sama tak kalau dengan sodium yang buang satu elektron? Okay, fluorine ions dengan sodium plus ion has the same electronic configuration, same as oxygen 2 minus and aluminium 3 plus. Okay, bila dia orang dah start ambil and buang electrons, dia orang punya electronic configuration dah become sama. Okay, so this is called isoelectronic ions, di mana dia orang punya electronic configuration samalah. And also neon. Kalau you guys tengok atom neon ada 10 electrons. So neon kalau you guys isi, dia akan juga dapat sama dengan this. Okay, so neon dengan fluorine minus, sodium plus, oxygen 2 plus, aluminium 3 plus has the same electronic configuration. They don't have the same number of electrons lah. Tapi there's actually a trend that we can describe dengan diorang lah. So, tapi first let's tengok ionization energy dulu. Ionization energy ni you guys belajar sekarang, and later on semester 2 you guys akan belajar lagi untuk ionization energy dalam thermodynamic. I tak salah. Ionization is the minimum energy, okay? Minimum energy required to remove the outermost electron from gaseous atoms or ion. Okay, so yang kita akan bincang the first dengan the second lah. Okay, untuk first ionization energy, maksudnya daripada atom to neutral, kita nak buang satu elektron, and kita tengok berapa banyak dia punya energy yang diperlukan. Macam untuk chapter 2 pun kita dah kira kan, untuk ionization energy mostly untuk single electrons punya atoms. Okay, and untuk second ionization energy, kita ambil this, lepas kita dah buang elektron satu, kita buang lagi satu elektron, so kita dapat 2 plus. Okay, kita nak tengok dia punya trend later on. And the last one is electronegativity. Okay, electronegativity is the relative tendency of an electron to attract to itself. So apa maksudnya? I'm not sure I dah give ke tak periodic table with electronegativity punya value. Ada ke? Ataupun saya punya periodic table yang saya bagi tu is only the normal one? If not, later I'll give you the periodic table with electronegativity values. Okay, what is electronegativity? Okay, maksudnya based on the elements, betapa sukanya kita nak tengok dia untuk ambil elektron. So example of elements lah, the electronegativity value lagi tinggi, lagi suka dia nak ambil electrons. So maksudnya lagi tinggi electronegativity values, lagi tinggilah chance untuk the elements untuk ada negative charge. Kan? Negative charge maksudnya dia ambil elektron kan? Dia curi electrons. Okay. Electronegativity values mostly you guys boleh tengok the trend lah. But I'm telling you that the highest electronegativity value is fluorine. Fluorine is very electronegative, and the highest value is 4.00. That is the highest electronegativity value. Okay. So let's see the trend in electronegativity. So across the period, okay, across the periodic table, okay, dah makin buruk dah periodic table ni. Okay, across the period, the electronegativity increase. Kenapa dia increase? Okay. The reason dia increase, kalau you remember, size tadi decrease. Okay. Kenapa size tu decrease? Is because effective nuclear charge dia increase. So effective nuclear charge, that effective is equivalent to proton number minus inner electron. So across the period, okay, the proton number increase kan, tapi the number of inner electrons stay the same, kecuali transition metals, transition elements. Ini je a special case. But any other atoms yang dekat lain ni, semua proton number increase, tapi the inner electron stay the same. That's why effective nuclear charge dia increase. So bila effective nuclear charge dia increase, okay, maksudnya tarikan daripada proton nak tarik the outermost electron tu is very strong. Okay, tarikan. So dia ada leftover tarikan untuk tarik other electron. Dia tak only tarik dia punya own electron, dia also tarik elektron orang lain. Okay, semangat dia untuk mencuri ni is very strong, that dia curi elektron orang lain. So that's why they tend to be more electronegative. So you guys boleh bayangkan lah, dalam banyak-banyak elemen paling jahat yang paling suka mencuri is fluorine. Fluorine dia suka sangat mencuri, sampai most of the time kalau fluorine ions dia akan F-. Very susah sangat you nak jumpa fluorine plus. Fluorine yang menderma ni susah sangat lah. Memang kalau boleh tak ada lah. Okay, that's why oxygen also dia suka mencuri, dia suka curi dua. Kebanyakan kalau oxygen, you nak tahu charge dia memang negative tu lah. Okay, going down a group, okay, remember, going down a group, apa yang bertambah? Size dia bertambah kan? Makin besar. Sebab dia lagi banyak principal quantum number. So size lagi besar, shielding effect increase. Bila size lagi besar, so this is the nucleus, size lagi besar, lagi banyak elektron yang dekat dalam kan. So elektron yang kat luar ni, dia dah tak rasa dah kasih sayang proton dekat dalam ni. So sebab yang elektron dekat dalam ni dah lindung dia, so that's why bila elektron ni dah tak rasa kasih sayang, dia pun sedih lah, dia nangis. So bila dia nangis, dia lagi senang untuk lari dari rumah. So elemen lain boleh ambil dia. So going down a group, the electronegativity decrease. Going down a group, contoh macam cesium, dia dah tak suka dah dengan elektron yang dekat luar sekali. So dia tak kisah dah untuk derma elektron ni. So ibarat macam going down a group, lagi kaya the element, dia ada lagi banyak electrons. Okay, you pun kalau you ada banyak duit, you dah tak kisahkan nak derma. Kalau duit you sikit, you macam fikirlah juga nak derma ke tak. Okay, going down the group, dah banyak dah elektron dia, dia tak kisah pun nak bagi elektron dia kat orang lain. So, cesium dia lagi selesa untuk dapat plus sebab dia nak derma. Okay, this is the trend. Electronegativity dengan across the group and down the group. Okay, across bertambah sebab dia makin kecil and Z effective bertambah. Going down the group, they decrease mostly sebab screening effect. Screening. Macam mana je screening lah? As screening effect. Okay. And lastly, okay, I akan cerita pasal acid-base character of oxide. Okay, this one most of the time question tak masuk, tapi adalah juga masuk. So kalau you guys tengok untuk period kedua, if I'm not mistaken, betul tak period kedua untuk sodium? Can anyone confirm it is period kedua ke period ketiga? Period ketiga kan? It is period ketiga. Oh, ada tulis kat sini. Okay, period ketiga. So maksudnya N paling tinggi is 3, right? So untuk period ketiga ni, this element is very special sebab diorang ada two karakteristik bila dia react dengan oksigen. Okay, untuk this tiga, we have metals, metalloids and non-metals. Okay, the first three is metal, sodium metal, magnesium metal, aluminium metal. Okay, that's normal enough kita dengar. Silicons is called metalloids sebab it has a metal property but it's not metal enough. Okay, and we have non-metal, phosphorus, sulfur, chlorine and argon. Okay, this characteristic it also produce differently when kita reactkan dia dengan oksigen. Okay, untuk metals, bila kita reactkan dengan oksigen, contohnya Na2O and magnesium oxide and aluminium 2O3, it is formed as basic oxide. Okay, untuk bila dia basic oxide, dia suka react dengan acid sahajalah. Sebab kalau you guys remember, base and acid, diorang ni macam musuh. So kalau boleh diorang nak lawan with each other only. Diorang tak nak lawan with diri diorang sendiri. So for metals, okay, the reason why aluminium is also considered metalloids, I'll show you later because aluminium is special one. Okay, untuk metal, kita reactkan dia dengan oksigen, dia jadi basic oxides, while non-metal, dia akan jadi acidic oxide and dia akan react only with the base. Okay, the special thing yang saya nak tunjuk tu is aluminium 2O3. This is special sebab it is amphoteric. Apa tu amphoteric? Amphoteric, it means that dia tak kisah, dia adalah macam orang yang atas pagar. So dia dengan basic boleh, acidic pun boleh, dia tak kisah. Dah jauh pula. So untuk basic oxide, okay, basic oxide dia sebabkan dia basic, dia suka react, dia suka lawan dengan acid lah, acidic hydrochloric acid. So dia boleh react and produce sodium ion, and untuk magnesium dia produce magnesium ion lah. Tapi kalau kita letakkan dia dengan a base, sodium hydroxide which is a base, dia tak nak lawan sebab dia orang baik lah. So macam family lah, dia tak nak lawan dengan family, so dia pun buat dirt je. So same goes to the acidic. So kalau acidic, dia kalau kita tambah dengan acid juga, dia buat de je, dia tak nak lawan. Tapi kalau kita tambah dia dengan acid, dia lawan and dapatkan silicon oxide 3 2-. One thing to remember, kalau question keluar, which is tak keluar lah untuk PSPM, kalau lah ada soalan keluar untuk you guys punya assignment pun, okay, banyaknya tak ingat lah apa jadi. Untuk remember, only have to remember untuk H2O. Untuk basic ataupun acidic, contoh basic dengan acid dengan basic, remember satu je, dia punya elements, which is dia punya compound, campur dengan apa-apa, contoh dengan NaOH, dia always dapat water. Dia dapat water. Water is a common byproduct. Okay, so actually this one is a simplified. Sebab kalau you remember, untuk acid, the definition of acid dia bagi H+. So kalau you tulis H+, also accepted as acid. Okay, untuk base, kita can also only tulis OH-. Okay, sebab dia adalah Na plus dengan OH-, while this is H plus Cl-. Okay, the acid part of HCl is this, and the base part of NaOH is OH-. Okay, untuk this, most of it you guys, untuk HCl dengan NaOH, itu je yang you guys perlu ingat. Dapatkan H2O, and other you boleh balance it by yourself. And one thing nak remember is, sinilah aluminium 2O3 ni, dia pening sikit sebab acid dia boleh, NaOH pun dia boleh. So dia tambah dengan acid untuk dapatkan Al3+ and H2O. The result, okay, usually you guys akan dapat ions. Okay, so the acid base character of oxide in elements in period 3. Okay, untuk sodium, which is metals, dia react dengan oksigen untuk produce the basic oxide kan. And bila kita tambah dengan water, basic oxide ni akan bertukar menjadi base. That's why it's called a basic oxide. Okay, and magnesium also a basic oxide, a metals juga, tambah, and we also akan dapat, kita akan dapat base. Bukan, base dekat sini. You also akan dapat base. Okay, and base react dengan acid. Okay, untuk any macam titration pun yang kita buat tu, kita banyak guna base and acid. Untuk any base ataupun acid, sekolah menengah pun korang dah belajar dulu, base campur acid, always you akan dapat salt and water. Okay, the salt is based on the base lah. Okay, untuk aluminium je yang special sebab dia 2. So aluminium as a base and aluminium as an acid. So aluminium as a base kalau dia react dengan acid. Tapi kalau jadi kita letak dia base, dia akan tukar jadi acidic, in which kita akan dapat Al2Cl3 and water. While untuk base, the water kita also included in the base, kita akan dapat the aluminium aluminate. Aluminium aluminate ni a useful organic compound lah, kita boleh guna in the future. Untuk this, most of the time the question, dia akan tanya which one is acid, which one is basic, and then dia nak equation. Itu je. So by hook or by crook, you guys have to remember the equation. So this is the non-metal, kan? Non-metal, kita dapat the acidic, and bila acidic, acid, kita mestilah react dengan base untuk dapat dia punya salt and water. Always like that. So phosphorus, dia punya acidic oxide, kalau kita tambah dengan water, kita akan dapat phosphoric acid lah. Sama lah macam tadi. So anything is either acidic ataupun basic oxide. Okay, either way, you tambah je dengan water, you akan dapat, kalau acidic you akan dapat acid, kalau basic you akan dapat base. So this is the question, you guys boleh try. And that's it untuk kelas kita untuk chapter 3. I know this is a bit longer, that's why yesterday I dah suruh korang minum kopi. This chapter 3 is very reading heavy. You guys kena baca. The only thing yang you guys have to remember is last kali lah, the acid and basic. You just know that which one is basic, which one is acidic. Otherwise, atas tu you just explaining the trends. Okay, untuk chapter 3, I give you guys, tak perlu hantar tutorials. Saya akan give you the tutorials answer. Siapalah tarik kursi ni. Okay, I'll give you the tutorials answer and try to check on how dia jawab soalan tu. Sebab for chapter 3, most of your marks will come from the techniques of cara nak jawab, which is the key point yang you guys perlu ada dalam jawapan you. Itu je. So chapter 3 tak perlu hantar. Chapter 2 you guys should hantar minggu depan, right? And Isnin minggu depan. And other than that, Jumaat minggu depan you ada UPS pukul 8 malam probably. Pukul 8 malam. If not, I think that's it for the class. Kalau boleh masuk ke dalam Discord and kita akan sambung cakap kat Discord and also ambil attendance. Okay, boleh masuk Discord. Pergi masuk Discord sekarang. Okay, so anyone tolong ambil the attendance untuk each of the class. So for chapter 3, like I said lah, dia panjang sikit just because banyak membaca je, that's it. Dia tak banyak pun konsep yang you guys kena faham. Most of it is baca. And just be grateful that dia tak masuk lah exam. So anyone have any question untuk UPS ke apa? Untuk UPS, please make sure you punya internet okay for the Jumaat malam tu. So Jumaat malam minggu depan, bukan Jumaat ni, Jumaat minggu depan. So make sure you ada, because you only have 10 question. Kalau you tak sempat habis ke apa ke, ada problem ke masa jawab, please let me know terus bagi tahu I, because kita orang takut you dapat kosong lah markah ke apa macam tu.